So we saw last time that if we took an alkyne and we added some H2 and Lindlar's catalyst, we get a cis alkene. But what if we wanted a trans alkene, right? Could we take an alkyne, add something to here, and then end up with a trans product? And naturally, since I'm talking about it, the answer is yes. And so the way we do this is through what's known as dissolving metal reduction. And it's called dissolving metal reduction because what we do is we dissolve a metal, and that metal goes on and does reduction on our alkyne to make it an alkene. And so we have our alkyne here, and then usually the metals that are used here are sodium metal or lithium metal in liquid ammonia, right? Again, that's going to be a very cold conditions, like -33 degrees Celsius. If you think about our sodium and lithium, these all have one valence electrons and they're alkali metals, so they're very easy to give up this extra electron. And so they're going to go to M plus and leave this electron behind, and then this electron is free to reduce our alkyne to an alkene. And through the mechanism that we'll see in a second here, we'll end up with the trans product for the most part. Right, obviously going to get a mixture of the components, but your major product will be the trans one. And so let's go ahead and take a look at the mechanism here. So we have our alkyne, and then we have our sodium metal with its one electron. This one sodium electron will go ahead onto one of our carbons, right? We have to use our half hook arrows because we're talking about the flow of just one electron. And then one electron from one of these triple bonds is going to move over to that same carbon. And then the other one is going to move on this other carbon. And so if you think about our products here, on one end we'll have two lone pairs, or one lone pair and a negative charge, and the other one will have a radical. And these things will form trans to one another. This is what's known as a radical anion, right? Because it's got both, and they're going to repel one another, and so they're going to be trans. Remember, lone pairs repel more than bonds. And so after this, it's relatively simple. We have some ammonia floating about. And this negative charge is going to go ahead and deprotonate one of our ammonias. Then we're at this radical. This radical will then interact with another sodium metal or just an electron. And the sodium metal is just going to go ahead and give it its electron. And then when it has this negative charge, it'll just repeat the process and deprotonate another ammonia to end up at our trans alkyne or alkene. And so, right, we know how to make our alkynes, and depending on what we want to do, we can reduce them in all kinds of different ways, right? If we want to add Lindlar's catalyst, then we can get the cis alkene. If we want to do a trans alkene, we need to use our dissolved metal reduction. And then if we want to go all the way to an alkane, we can just use our hydrogenation catalyst. So you can see we have a bunch of control over alkynes.